Good morning, everyone. I'm Sharon Hsiao from Arizona State. I'm an assistant professor from School of Computing Informatics, Decision Systems Engineering. This is computer science. So today, we're going to share the work that my team is currently actively working on with some results and visions and what's the current state. And today's agenda, I basically will lay out the broad strokes, our visions, and what's our approach and proposed methods, and just briefly of the findings. So Arizona State University is one of the largest public schools in the United States. Last year, we admitted 18,000 bachelor's undergraduate students in engineering school. Computer science alone, related programs is 3,800. So that was our last year. This year, we increased a little bit too. So just on my way to work, then I stopped in the traffic. There was literally words on the street that ASU is the #1 of the US for innovation. Oh, just saying. So the work that I'm presenting, the problem is that we have still majority of those programming classes. They are blended instruction classes. So what are blended instructions? That means we have the face-to-face lectures in class, and then the lecturer, the instructor, gonna support several intelligent tutors, self-assessment tools, etc., or at least the course management tools for students to use outside the classroom. So currently, this is still the primary and preferred ways even we use in ASU for those majority of all those computer science classes. And the benefit of this is that it gives us teachers the great flexibility in order to instruct the topics, and it's easy to proctor all those exams, and just for the sake of convenience. And also, it prevents from academic dishonesty. Say, for example, as much as we wish every student bring in their laptop to have the exams over their laptops is harder to control during the lab. Well, so that's why we design usually the assignments for them to take home to actually work on those problems, but we conduct the classroom paper-based exam. So what's the problem over here? The majority, the lower division programming courses, if you take all those paper-based exams, these are gonna happen. They're gonna have the return exams with the graded and most likely without any feedback. With feedbacks, probably highlight the place that you have some misconceptions or errors, and at most the TA or the graders most likely write down the main thing. Say, for example, what thing is missing, which unfortunately in this case is not really the key concept. It's just missing one peripheral concept. So this is happening in those more traditional blended classroom, but this is the majority. So then a lot of advanced learning analytics cannot be used unless you actually take those quizzes, just learn online and don't come into the classroom. But we take formal assessments through this way. So our goal is trying to bridge the gap from outside classroom and inside classrooms to be able to collect more comprehensive data points. So the related work here is that while there are several tabletops, Robotos is probably going to present next, then also the smart classrooms, you have the wearable technology to be able to collect students' learning activity. But in this case, if we don't use, like clicker, any quizzes during the class, and you still take formal assessment, all those details, conceptual levels of concepts or misconceptions will not be captured. Instead, just each quiz, each question's final score. So what we are thinking is, before we use smart technology, which the major criticism could be not just the cost, but maybe it's more workload for the teachers to learn how to use those and to be able to manipulate all those dashboards during the class and construct and instruct the lecture as well. So what we want to do is to just take away, provide a practical solutions for current majority blended classroom. And we want to capture all those data and provide it through the visual learning analytics, which they are currently using from other supplemental tools, such as self-assessment tools, and combine this together to let them know more up-to-date their learning performance. So our goal, again, is just trying to bridge the gap between the lecture-based classroom and the ideal technology-enabled ones over this visual analytics. So specifically, we want to provide a solution that's for teacher to continue using the paper-based exams without learning another authoring tools to create exams in order to take the exam online in such a way to capture those analytics so they could benefit from the learnings activities up to date. But the bigger picture over here is to be able to provide personalized feedbacks via just through the visual learning analytics, so they could get more feedbacks on their paper-based exam and no longer just cross no feedback, zero, I almost get failed, something like that. So to do this, we designed, we take the semantic approach. So because we want to focus on not providing the feedbacks just about, well, I'm missing, printed out the strings or missing particular something. We want to address that's actually the concept that you do not have. So we want to design this visual analytics to be a semantic way. So our research architectures actually is really big. The difficulty, the challenging here is try to capture and deliver. So to capture all those data points, because that's paper exempt, we actually have to know where they go wrong. So we developed the analytics API so that we could receive whatever we capture from physical paper exams, and the other way to integrate whatever is outside there, those supplemental tools. So what we do here, I'm just gonna focus on the tool that we are using. So we designed this, we call it Agile Analysis. It looks like a course management tool that you could create the classes, you could create an exam. So once you create an exam, you just need to one simple click, which is choose whatever the doc format of your exam file, upload it to it. We will extract all the patterns of your quizzes or questions. So it will look like, once you upload it, first thing you will see is an overview of whatever the exam that you design for this class, which is, in this case, it gives you the overview of my entire exam, what's the distribution of the higher level concepts, and those concepts corresponding to which questions within this exam. So you will know whether I'm putting too much emphasis on just one single concept or just one single group of the concepts, or I don't really have a much balance of that. So, and then what you will see is all those questions will be extracted from the exam. Whatever, usually I would use Word to create all those paper exams. So not just that, we will extract the content, which is normally combined with natural language, how you ask the students to look for the question text, and also possibly some programming codes. So we will extract the concepts, automatically index what's actually related to this. So not just that, this is actually an authoring interface. So if you feel like this is a midterm, you want to emphasize this key concept, you can zoom in and out in order to adjust the weights of those concepts to put the focus on that. So say, for example, this one we actually index, automatically indexed by this, constants, loops for, and also the primitive data type. So this is a teacher's dashboard view that once the students, they finish their exam, your TA still have to grade it, and now it's the key. How do we actually input each questions back to the systems? First questions, I got partial credit, or co-writing questions, I lost 1 point. So this part, we have two methods. Initially, we use, let's just create the interfaces for the TA to look for each question and enter in. Whenever you finish, use the red pen grading the entire exam. But turns out this process is really tedious. So then we eventually design a different approach to capture this. So I'm gonna talk about it really quick. So this is a student's view. So what they see is this is a student's progress, not progress, just their knowledge actually represented formal assessment for this exam compared to the rest of the class, which is anonymized. So then here I would also compare to the students, their performance to the average of the class or the best of the class. And you will be able to reference to which question you actually get it wrong. So those are the best interfaces look like. So what we do is, how do we do this automatically index? Is that we presented last year in LAK, we use topic modeling, which is a variation of that. We call it topic facet modeling. It combines natural language and programming language to be able to extract concepts from short text rather than a big corpus of the text. For example, here, this is the sample questions. Write the following for loop as a while loop. And the question provided a for loop. So obviously, if we just use programming language parser, then we will know this is about iteration for. But it's not just about the syntax for. You also need to understand the for loop as well as the while loop so that you will be able to do this conversion. So that's why we want to actually combine not just the codes itself, but also be able to recognize some natural language. So again, the goal of having this dashboard is try to bridge physical and cyber digital programming learning. And our approach is to collect students' performance and try to be able to capture the semantic level by identifying all those concepts for each question. So what we want to do is to use this concept and question pairing to provide as the feedback for the students, for them to know when you get the partial credit, you have partial misconceptions or partial concepts are gaining for this particular question. So the challenge is, as I said, the delivery, the capturing is hard. It's not a trivial task, but good news is that we have a solution. So we use a mobile device and to capture whatever their written codes, which pre-generated QR code with the question. So we will know this question corresponding to what set of concepts. So once captured this, that we will be able to know what concepts actually related to this. So now TA just use this mobile device to configure the concepts. So now these concepts, we will also be able to use it to systematically calculate the partial credits. So, because in our earlier findings is that human graders, however we train them, give them the coding schemes, ended up they still share inconsistency when they grade through the entire class, especially the co-writing question. So this is the technology part. So what we did in evaluation is that first, we need to be able to ensure that automatic indexing actually works. You are indexing the correct concepts, you are indexing the meaningful concept. So this is our first step to approach evaluating this project. So what we do is that we hire two experts who have the experience to teach this course, and we use their exams, 4 of their exams, a total 76 questions, and ask them to index the key concepts and all related concepts from a provided Java ontology. So what we found is that if we split all those questions by their complexity and ended up the complex questions, the automatic indexing could actually index significantly higher than the experts, which is not surprisingly because for the algorithm, we are able to recognize a range of peripheral concepts. But now the question is whether they are the key. Right, so then we also split whether the questions is procedural type of questions and declarative type of questions. So usually the simplest split is by multiple choices questions and the co-writing question to know whether you need to apply the knowledge or actually need to define the knowledge and apply to do something else. So we find that automatic indexing actually achieve a significantly higher as well. And some subjective feedback that we found from these two experts is that, well, it seems very convenient to use and be able to provide feedback for the students, but they worry about whether the precision. So we also have some other evaluation metrics in order to identify those, which is not reported right now because we just finished this evaluation to calculate whether we cover as many as possible of those concepts that needed to be addressed for each question. The other thing is whether we are able to identify all the keys. So to summarize, actually, we just finished collecting those data and just finished evaluating, MTurk, we set up all the criteria to find the experts to index all those. And we also set up another expert study to index all the questions that we in our corpus. And our next step is to investigate how students, they actually use this kind of feedback provided to them so that we will be able to connect the physical and digital the programming activities. So, well, thank you. I'll take some questions.
Yeah. And I'll let you pick the questions, but I think for the people at home, I think we have to turn this on.
Well, as Leonardo just won this Reverend movie from Oscars, he said global warming is real, it's happening, and we shouldn't take the world for granted. So what I would like to say is computer science for all is happening, it's real. So we are very seriously about this, and we don't take a current, today's programming classes for granted.
Questions, and anyone know the secret to these microphones that don't appear to have buttons on them? Or magic over it? Questions for a speaker?
No. I'll be around the conference.
Yes.
I have a question. Well, it's very interesting talk, and especially that slide when you pose a problem that is very important, but we don't tackle, that is bridging what is happening face to face in a blended. Is it working? Yeah. In a blended scenario. And I was just wondering, why is this that is happening? That we focus on the online part and not necessarily on the face-to-face part. It's very nice to see your approach to the problem. So I was thinking about I was wondering what are your thoughts about the future in this area, where we need to make this bridging, and what possible solutions besides the very clever solution that you found can be taken in the future.
Well, thank you. Actually, Monday we have this pre-conference event called Cross LAK. So a lot of interest actually are here. I try to address, because more or less you face this problem, a lot of learning activities outside classroom, online, a lot of learning activity in class. So our rationale is simply trying to provide help of what we know is working, of having those formal assessments in class, but we are not able to provide them personalized feedback. So what we want to do is to at least, let's do this first, And the benefit of this is be able to really collect the detailed data of those. So then just as the closing keynote can just address 2 days ago, or yesterday, 2 days ago, that it's a data-driven iterative engineering. So once we collect this, then we are able to model to know better, which is typically we just use their final assessments or just a first exam assessments score. But what we could do is better.
We do have time for one more short question. And you're, no?
Now the
no.
pressure. No.
Yeah, pressure. No, it's on. Just
Right. Yeah, now the pressure's on to be short. This is very interesting, but it looks like mapping the concepts to all of the questions requires a fairly high level of front-loaded activity for the faculty to do all that mapping. And I wonder, A, if you've given any thought to the cost of that, and B, do you anticipate a large number of faculty perhaps being resistant to that level of work?
Right. So we realize it's gonna be work for teacher, which usually teacher tend not to do that. So which is the same thing like orchestration. If you use a smart board, smart classroom, the teacher have to learn that. So what we want to do is don't make them extra work. So that's why we provided this automatic indexing. So now so that's why to ensure the accuracy is actually very important. But this could be learned through iterations of the training. Say, for example, we just use 2 classes, which is right now we have 3 classes are using that. So we could have the algorithm to actually learn from the teachers configuring those weights. Then the algorithm will be smarter next time.
great. All right, that's all we have time for. We have a short break.